Thank you so much. Yeah, really excited to be here and really excited to be talking about such an important topic. So for a little bit of background, I'm Trevor Slattery. I'm coming out here from San Francisco, California in the United States, and we're going to be talking about where we're finding good use cases for AI and penetration testing, what's been a bit more of hype, and what's actually really effective. All right, so of course, AI is the latest and greatest thing. It's changing security across the board, and it is seeming to seep its way into just about every industry. With penetration testing, there have been a lot of use cases for AI, and we found that some work a little bit more effectively than others. So, our main point that we want to make here is that AI should be used as a force multiplier, not a crutch. AI is not here to replace penetration testers. It's here to make them more efficient, more effective, and streamlined. Some workflows are going to see a massive acceleration, while others aren't going to be quite as well changed. We want to make sure that we're cutting through the noise and seeing exactly what matters. We have tested these projects on real client engagements with live devices to understand exactly what is effective and deliver the maximum results. This allows us to have a clear line between real, genuine effort and wasted effort that's not going to deliver results. So, what we're looking at for this evaluation. The main metrics that we're going to consider, one of the primary ones is time saved. As a penetration testing firm specifically focused on medical devices, oftentimes time is of the essence. If we can shave down a matter of hours on an engagement, that can be critical with some of the life-saving technologies that we deal with. So it's vital to see how much time we can save. It's very important to measure the accuracy of our results as well. AI is a great tool, and it is unfortunately prone to some problems where it may not always produce the most meaningful or the most accurate results. We want to make sure that we're delivering maximum value in a truly effective way by using AI. Another very important part is going to be reproducibility. It's very difficult for us to say that we were able to find a finding once without being able to prove how we found it and deliver actual value to the clients that we're working on our engagements with. Now, this will tie back into making sure that we're getting good results, but there's a risk of confidence here. This is why we use it as a force multiplier, not as a standalone system. There's a major risk of AI providing false confidence, especially to the penetration testers, that there's something there when there really isn't. And finally is, of course, going to be what is the cost of integrating AI? AI costs are ballooning by the day, and we want to make sure that this is well managed and still is delivering cost-effective value. All right, the first thing that we're going to talk about is where AI wins. These are some of the use cases that we've found that work the best, that are going to deliver the most value, and that make sure you're using AI effectively for your penetration testing. So we've found 7 main areas that are going to be consistent winning factors. Report writing automation is going to be, honestly, one of our highest ROI items. We're going to dive a lot more into detail about this and talk about how we make sure we're protecting data while still speeding up our team for what is, as everyone knows, a penetration tester's least favorite part of the engagement is the documentation. We use it for early guidance with threat modeling, with test case development. Now, this is very important that we lean into guidance. This is not going to replace the manual element of generating the threat models, of generating our test cases. We instead want to use this as a starting point and then further refine it manually. We're also going to look at how we use it for fuzz testing and fuzz script generation. Again, this isn't somewhere where we want to replace a fully functional fuzz testing tool, but for something quick, something on the fly, something that we really want to run to ground, this is a great way for us to do it quickly. And so when time is of the essence on these engagements, we're going to lean heavily into this process. We like to look at it for some scripting, for some tool development. Again, this is not meant to dedicate to a very strong, powerful tool. We aren't trying to reinvent something like Nessus or Nmap that is an integral part of every cybersecurity tester's toolkit. We're trying to enhance these. We're trying to add some benefit while speeding up our testing process. Now, one part that we face quite frequently as penetration testers is developing custom code, custom tools, custom scripts, and unfortunately it doesn't always go as planned. AI is a great tool to allow us to streamline this process, and we can go through some great error debugging here. I can give a little example of this one actually while we're mentioning it. So last week, we were performing an engagement on a medical device. This was a high-risk profile medical device with very sensitive use cases used during surgery. We were trying to test some NFC tags on the device to determine if we could read off of them, but we were running into problems with the firmware using a Proxmark, which is a tool specifically for IoT testing on NFC tags. We couldn't figure out what was going on. We were trying to debug the C code compiler, and we were able to actually use ChatGPT to pretty effectively understand why the compiler wasn't going and load custom firmware onto these tools to allow us to execute the engagement successfully. Another great thing that we want to look at here is analyzing network responses. Now, I do want to emphasize again, this is not something that can just be handed off to AI. It's something that we can do in conjunction with manual review and with refinement of the process. All right, so we'll dive into a bit more detail on report writing automation. Like I mentioned earlier, this is what we find as the highest ROI on our process. This allows us to draft initial findings, provide some high-level recommendations, and identify some early risk ratings. A great thing about AI is we're able to build out the context of the project that we're working on. So when we see a vulnerability, it may have a different scope of impact in one product to another. We want to understand what those differences look like. So we clearly define that, and we're able to streamline the process going through there. We're able to take a lot of the notes, the artifacts, the quick, just jotted down details that our testing team identifies and map this into a client-facing deliverable that gives them the information they actually need to fix these problems when they've identified it. Now, one very important part about this is we still require human review of anything that we're putting out. We do not want AI to run wild here. And another thing that we want to cover here is what information we're passing into the AI. During a penetration test, we're accessing sensitive information, we're testing very sensitive products, and oftentimes we have a lot of intellectual property that would be catastrophic if it was disclosed. So how do we solve this problem while still feeding it into AI? The solution that we have identified is to take the notes, take the images, and take the evidence that we've identified through testing. We're able to hash it, and we're creating a mapping value where we instead inject the hash of those artifacts into the report, where we then have a non-AI code tool. I know there aren't too many of those left these days, but then we have this tool replace it with the hash value so that we aren't exposing the AI to sensitive information that our clients would not to potentially be exposed to OpenAI or Anthropic or any of these companies. This is a way for us to remove some of the risk while still streamlining our process significantly. All right, diving into threat modeling and test case development. This is a great way for us to hit the ground running fast, especially with us operating in the healthcare space, a very tightly regulated industry. We need to have a clear understanding of what we're doing before we start testing. This is where our threat modeling begins, where we stem this into our test cases. We want to understand what could go wrong with the device and how are we going to test if this can go wrong. Threat modeling is a great way for idea generation. We can use AI for a first pass, get us part of the way there, and we'll finish it up with some more accurate context. Once we know that, we can try to understand, well, let's say we're worried about disclosing sensitive data in plain text. How are we going to go and test that? AI is a great tool to develop these test cases and allow us to speed up the process there. It's fantastic at identifying some attack surfaces that might be forgotten or certain vulnerabilities that we might overlook during a typical engagement. And the great thing about AI is it's going to build upon the context of what we've already been doing, and so it's going to have all of these notes and all this information that we're feeding into it. It's great when we have that context. It's not when we don't. It's very important that we're building up appropriate context for these tools. We need to have the right information, and we need to make sure that it's used effectively by the AI instead of just saying, generate a threat model, generate test cases. That's never going to deliver meaningful results. All right, on to fuzzing and scripting. Now, this is a very tedious process at times, is trying to identify a specific field or a specific connection where we want to spike it with as much data as possible to see if we can force unexpected behavior, a crash, identify an anomaly in the software. Now, AI is not meant to replace a dedicated fuzzing tool. What it does very effectively is it allows us to quickly burn through some small test cases and identify what might be the areas of most concern in the device. If we're able to see anomalous behavior through fuzzing on these quick test protocols, we can then refine this behavior with a dedicated fuzzing tool. But fuzzing tools are very time intensive and can be very expensive to run. We don't want to allocate them to resources that we're not sure if they're going to be super effective here. One thing that I do want to give you a little prelude into some of the use cases that we see don't work is generating random input for fuzzing. This works well when we use structured input. We understand what should be fed into it, or more importantly, what shouldn't be fed into it. But we can't just let this run wild and try to generate random output. AI does not do that very effectively. Another thing that we like to use here is going to be for debugging and analysis. When we're looking at any errors that we're getting from a script that we're running, any errors that we're identifying in a product that we're testing, we want to have an understanding of what does this actually mean? Is there anything that we're missing in an HTTP response that's forcing an error? Are there any small details that we can pick up on that the tester might have missed? AI is a great tool at pointing out some of these details. We need to verify them, but it does a lot of this initial legwork that would take our team a lot of time to do in the past. All right, we're going to talk a little bit about where AI falls short of expectations. Now, like I said, AI is being fit into just about every use case, every industry, and every product. We want to make sure that we're using it where it's most effective. And in a lot of cases, this can actually hinder our team and make testing less efficient as opposed to streamlining and augmenting our team's capabilities. Now, I already alluded a little bit to the randomness problem of AI. AI does not do a very good job at randomly generating input based on whatever criteria you give it. This is something that you can test at home. You can go into ChatGPT and ask it to generate 100 random passwords, for an example, of a specified length. And you will notice often that these are going to be material similar with just minor modifications. It's going to do similar when we're trying to generate word lists to cover a lot of ground, when we're trying to generate input for more aggressive fuzzing. So when we're going through these processes, we need to be a little bit more careful. We have found that AI is not always going to be the best at automated exploitation. Now, this can be not always the case. There are some times where we have a vulnerability that we've identified. We just need to get it in the final stretch, and we're not exactly sure what we're doing. If we have enough context built up, and if we have enough information for the AI, oftentimes it can do this well. But this is not always the case. If we don't have perfect information and perfect context, it's not always going to be as effective. What we often see is generally with that information and context, our testing team would be able to exploit it just as effectively manually, if not more so. We see that AI can often fall short when it comes to widespread reconnaissance and open source intelligence gathering. Now, when we're looking at a specific functionality, a specific page, something of that nature, AI does a pretty good job at covering a lot of ground. But when we're saying, let's pick a domain, tesla.com, and we want to start identifying vulnerabilities within that domain, cover as much ground as you can, find any subdomains, and flag what is of the most importance. It's not always going to do the best job at that. This can be augmented by giving it specific skills and specific tool sets, but this is going to dive more into security-specific harnesses as well. When we're using AI as a general tool without using it for dedicated resources, it's not always going to deliver the same results. Now, the most important thing that I want to emphasize here is unsupervised workflow execution. It's vital for us to have a human in the loop throughout this full process. We want to avoid the risk of A, letting an AI try to test a system autonomously without someone supervising it for a couple of reasons. I already mentioned that we're dealing with highly sensitive information here. Let's say it is able to find a vulnerability and it is able to access this information. We're not necessarily going to be in control of what happens to that information without a manual review process. We need to make sure that we are supervising anything that these tools are doing to use them as effectively as possible. AI is also not always going to be the best at finding validation. This will go back to building up all of the context that we have. When we're trying to look at a specific vulnerability and see what was the criteria that really led to this happening, can we make sure that this is reproducible, and maybe can you generate a proof of concept for it? We've seen some success with this, but in general, this is something that is more effectively used as a manual process. Oftentimes, it's actually slower for us to do this in a more automated process with AI without it having all of this context that we need. All right, so I want to dive into a little bit more about the recon, open source intelligence, and wordless. AI-generated wordless can actually sound really good. But this will go back to what I mentioned about trying it with different passwords. You're going to see more similarities than differences in a lot of cases. This is not going to be the most effective way to go about this process, especially when there are great existing tools out there. For an example, SecLists has tons of different word lists that you can burn through on an engagement, and it's going to be more effective to use these as opposed to trying to generate it from scratch with AI. Another important fact is, let's say we're trying to do a security engagement against a hospital. Now, the weakest link in the security chain is very often going to be that human element. So when we're trying to look at things like passwords, we're going to guess based on behavior. What is the address of the hospital? What season is it? What year is it? Trying to guess first dot last name, things like that. Unless we're building this context into the AI, it's not going to do this very effectively. This is usually a more efficient process to perform manually, as opposed to trying to refine and tweak and build up that information for the AI to run away with. For open source intelligence gathering, one of the biggest problems that we run into is hallucinations. If we say, go look up everything you can about this individual so that we can try to refine our password guessing process, and it says that, well, this individual has a dog named Charlie. That may not actually be true. We don't know where it got this information. Maybe someone else with that name has that dog. But if we waste that effort on trying to guess that password name, it's often going to burn more time than it would save us by trying to use this process. Now, recon at scale is a high volume process. We're generally trying to look for the weakest links and trying to look for what is the biggest focus here. There are a couple of risks that we see when we're doing this with artificial intelligence. The first is going to be missing some information. It's surprisingly easy for us to miss key details when we're going through this process and omit some critical steps that would be very, very valuable for us. This is especially important in bug bounty hunting. Now, where we're typically stepping into the space is for penetration testing against a refined scope. We know exactly what we're supposed to be testing, and we know exactly why. When you're looking at a bug bounty hunting program, such as that put on by HackProve, you're generally trying to cover a lot of ground quickly. And so these small details are more important earlier on in the process. Now, this will also go back to existing tools. There are a lot of fantastic open source security researching tools out there. Amass, Subfinder, Nikto, all of these are going to do a great job at covering a lot of ground very quickly, identifying what are some of the targets that you should look a little bit more into and what maybe is just going to be noise. When we see using these tools to tie it back into what is the most effective, that is where we're going to get the most value. We see that AI is not going to be the best for quick automated recon. Okay, well, how can we use AI as part of this process? Maybe we're going to start with our discovery by using Amass, and then we're going to refine these results and feed it into AI to start developing our threat model, start developing our test cases, and understand where do we go from here. We have all this information, now what do we do with it? That's a great use case for trying to cover up AI's weaknesses while still getting high-value results. All right, now diving into exploitation. Now, like I said, sometimes we do find some good success with this, but it's going to depend on how well you wrap the harness around your existing AI model or how well you have trained your model for this specific task. For a lot of security researchers, this is not going to be a feasible effort. You're likely going to be using a lot of existing tooling. When we're diving more into enterprise-grade security, this can be a little bit more of a refined process. But in general, when we're looking at AI-generated exploits, oftentimes they can give us good output, but it doesn't actually mean anything. We've even seen AI-generated exploits hallucinate real findings that it thinks it discovered throughout the process without actually being able to have the evidence behind it that proves this is a real vulnerability. If this is something that can slip through unchecked without a human-in-the-loop review process, and this is delivered to a client who is trying to get meaningful results out of this engagement, they're not going to get any value of this. They're going to get noise as opposed to real signal on what actually matters. even when we're using this to try to reference specific vulnerabilities. We've seen it hallucinate CVEs. We've even seen it hallucinate CWE categories that just don't exist. It's saying I was able to identify a specific vulnerability here, and that vulnerability is not a real problem. We want to make sure that we're actually focusing on what matters as opposed to just collecting a bunch of data here. All right, now when we're diving into finding validation, this can be a little bit of a better process, but it's still not something that we're going to get a ton of value out of. Finding validation, once we've identified a vulnerability, is going to be us actually looking through and making sure we can reliably reproduce this, and most importantly, we can explain what is the impact and how do we mitigate it. For any engagement, any penetration test, any bug bounty program, the most important part is saying, what can we actually do about this? When we're trying to validate findings and we're trying to develop proof of concepts that allow us to go through this process, AI is not going to be the best at automating what a tester has already done. Oftentimes, it's going to be more effective to collect the notes, collect the steps that the tester performed, and try to script that out manually. It's a little bit more of a streamlined process as opposed to handing the wheel over to AI here. Now, we want to make sure that we are still validating everything with a real proof of concept. Anytime we're identifying a vulnerability, this can be either through a penetration test or through a bug bounty program, we need to make sure that this is a real problem. This isn't something that can make its way as a false positive into a report. It's never a good look when we're delivering a report without actual meaningful value and without findings that matter. So we want to make sure that we have strong coverage here. All right. Now, one thing that we see a lot of penetration testers fall into is the over-automation trap. And it's easy. I can admit that it's something that's happened to me in the past before, trying to find ways to streamline things as much as possible. Streamline everything you can and speed up your process. And there is a point where this can be really effective, and there's a point where this can stop. We can go back to some of the examples of what worked well. For automating the report writing process, this can often take over 10 hours to generate a meaningful and quality penetration testing report with a manual process. With AI, we can often get this down to even sometimes under 30 minutes, as long as we have accurate notes and detailed information that we can provide here. This is a great way for us to automate the process, but if we were to just say the set it and forget it approach, leave it with a target, leave it with a product, and say, try to hack into this and create the report, it's never going to work effectively. This isn't just a problem within penetration testing. This is going to be across the board with cybersecurity and with a lot of different AI use cases. We want to make sure that there is still a human in the loop, as it's not always going to be perfectly accurate. When we're going through autonomous scanning exercises as well, this is one thing that can be really sensitive, especially when we're dealing with high-risk environments. We can take a look at a hospital, a casino, places where a disruption in service can mean massive loss to revenue, potentially even the harm of individuals or the loss of life. We need to find a good way to prevent this. AI is not going to know what a safety critical system looks like, and it's not going to know how to compare that to a less sensitive system. It might run wild and try to exploit things too aggressively, especially in some legacy systems. We're going to think within the industrial control and automation system, or within the medical space, where we're seeing old tools. We're seeing Windows XP still even. If we try to attack those, we can often take those systems entirely offline. And a skilled penetration tester is going to know that, and they're going to try to mitigate this problem. AI might not have that context, and it might not have the right information. So we want to avoid this over-automation trap and make sure that no matter what we're going through, we still have this human-in-the-loop involvement. We are not letting anything slip by. All right, I'd like to go through a couple of key takeaways, and then we can turn it over for any questions here. So using AI for report writing, threat modeling, fuzzing, and quick script generation is a great way to augment your workflows. I'm going to go back to what we talked about. This is a force multiplier. It's not something where we can just let it go with the set it and forget it approach. But using it to augment your capability in these ways is often going to be A, some of the most time-sensitive areas for a penetration tester, and B, it'll speed it up quite effectively. Do not always trust AI for word list generation, automated recon, or automated exploitation. Now, as I've said, this can work, but we need to make sure we have the human in the loop element no matter what we're going through. Always, always, always verify any output that you're getting out of these AI tools. We need to make sure that they're accurate, we need to make sure that they're real, and we need to make sure that we aren't just delivering noise. And And one thing that I want to talk about as you're looking at integrating AI into your existing workflows is start small. Don't start with trying to link report writing, threat modeling, fuzzing, and scripting all in at the same time. Start with what is going to deliver the most value to you. If you find that you spend over 30% of your engagements dealing with report writing, that's probably going to be a good place to start. If you're identifying that you have a hard time understanding of how do we get test cases once we identify what could go wrong, that's going to be a great point to start. As you start building out the process, you'll be able to refine this more and more, and you'll be able to deliver actual meaningful results throughout your engagements. All right, thank you all.